So this should be recording. Alright, so chapter 2 is about set theory. So what is a set? A set is a collection of things, distinct or different things. Those things are called elements. So here's a couple of examples of sets. Set A contains the elements 1, 3, and 10. Set B contains the elements n, x, 0, 10, and 23. And if your set is, like this, where it's just a list of elements, then or even if it's just one element, you always have to put these curly braces around it, okay? And just do your best. I know they're kind of difficult to draw. So this symbol right here means is an element of, and if you cross through that, means is not an element of. And then this is the empty set. So that is the set that has no elements. And this means the set of all natural numbers. So those are all of the whole numbers starting with 1, 2, 3, 4, 5, 6, 7, and so on and so forth forever. So that's the natural numbers. Okay, so we want to look at another way to describe this set. So this set starts at 10, and it has 10, 11, 12, 13, and then the ... I'm assuming it has every other natural number after 13. So another way to describe this set, which is called set builder notation. So you may see that on your homework. They might say, use set builder notation. So that could be x such that x is an element of the natural numbers and x is greater than or equal to 10. So this is saying basically all values of x such that x is a natural number and x is greater than or equal to 10. So that's one other way of writing this set using set builder notation. You could also have chosen to do x is strictly greater than 9. You could do it that way too. So this is the roster method, and then this is set builder notation. So the roster method just means you just list them, and that's it. So then if we want to write the set described using the roster method, all letters in the word carry. So we would just list them. We would have the curly braces. So we have C, we have A, we have R, and we have Y. And that's why, and you don't write the same thing twice. You only write each thing once. So that's what it means when it says, a set consists of distinct elements, different, so they're different. You don't list the same thing twice. I guess on number 1, we might also want to describe that just using words. The set of all natural numbers greater than or equal to 10. All right, so number 3, we're going to want to rewrite this using the roster method. All numbers less than 4, all natural numbers less than 4. So using set builder notation, it would look like this. X such that x is an element of the natural numbers and x is less than 4. So the natural numbers less than 4 would just be 1, 2, and 3. So the set just is a set containing 1, 2, and 3. Alright, so number 4, x such that x is an element of the natural numbers and x is greater than or equal to 7. So if we want to use the roster method, we do 7, 8, 9, 10, ... And then number 5, x such that x is a month that starts with J. So we have January, June, and July. And number 6, x such that x is a natural number less than 1. So what are the natural numbers that are less than 1? Nothing. So this set is equal to the empty set. Alright, so set A basically looks like it's got all of the even numbers from 2 up to 24. Alright, so true or false. So number 7 is saying 2 is an element of A. That is true. Number 8 is saying 10 is an element of A. That's also true. Number 9 says 12 is not an element of A. That's false, because 12 is an element of A. And then number 10 says the set containing 4 and 6 is an element of A. That's false. Okay, because the elements, 2 is an element, 4 is an element, 6 is an element, 8 is an element, but a set that contains 4 and 6 is not an element of A. Now, it is what we call a subset, and we'll talk about subsets here in a little bit. So if they said that this set containing 4 and 6 is a subset of A, that would be true, but it's not an element. Alright, so the cardinal number of A is the number of elements that are in A, as represented like N of A. So in this case, let's see. So we've got the even numbers from 2 to 24. So I think basically it should be 12 total elements. So like if you did 24 minus 2 divided by 2. Oh wait, sorry, that'd be 11. So let's see. Let's just make sure. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So that's actually 12. Okay. So we need to add 1 to that, I think. Maybe that's the ticket. Add 1. That's 12. So you mean like how you had to, divide it and all that stuff and add 1?
More or less how you just ran the last two divided by 2 plus.
I think that's like a formula, I guess. Like, so this was the biggest number, this was the smallest number, and it was basically only the even numbers, so like every other number, so that's why we divided by 2. If they were like counting by 3s or something, you divide it by 3. And then add 1, because I guess when you do this, you're not counting one of these.
You just do 24 divided by 2.
Yeah. Yeah, but there might be some other ones, like if you'll remind me later, maybe we'll pull up the homework and look at some of the examples they have on there. That'd probably be the best thing to do. All right. So if the cardinal number of set A is equal to the cardinal number of set B, then they are said to be equivalent. And if they contain the exact same elements, then they are said to be equal. Okay? So they're equivalent if they have the same number of elements, and they're equal if they're literally exactly the same. So number 12, set A has 1, 2, 3, 2, and 1. And like I said, you're not supposed to write the same thing twice, so we should kind of simplify that to just be 1, 2, and 3. And it technically doesn't matter what order you put them in. Okay? So they are equivalent because they both have 3 elements, and they are equal because they have the exact same 3 elements. So number 13, A is 6, 7, 8, and B is 7, 8, 9. So they both have 3 elements, so they are equivalent, but they're not the same 3 elements, so they are not equal. And then number 14, A has 3, 4, and 5. B is all of the natural numbers that are greater than or equal to 3 but less than 6. So for B, that's going to include 3, 4, and 5. So in fact, they are equivalent because they both have 3 elements, and they're equal because those are the same exact 3 elements. All right, so then we'll look at the difference between finite set and an infinite set. So if the cardinal number of the set is either 0 or a natural number, then it's said to be finite. Otherwise, it's infinite. All right, so the set of all living humans, is that finite or infinite? Not really. I mean, at this very moment, there's a certain number of humans on the earth. I mean, it may be kind of hard to pin that down, but there's not an infinite number of beings on the earth. All right, so number 16 is all of the natural numbers that are greater than 500. That is infinite. And then all of the natural numbers that are between 1 and 2,000. That is finite. All right, write the following set using set builder notation. So number 18, 5, 6, 7, 8, and so on and so forth. So that's the set of all, so that is x such that x is an element of the natural numbers. And you could either say x is greater than 4, or you could say x is greater than or equal to 5. And then for number 19, that looks like all of the natural numbers between 1 and 87. So that would be x such that x is an element of the natural numbers. And we could just, actually the simplest way to say this would be to say that x is less than or equal to 87. We don't even really need to include the 1 because that's already understood by the fact that it's the natural numbers, because the natural numbers start at 1. And then for,
Sorry. Is that a simplified, or like, that's the answer period? I mean, could you do the 1 and the...
I mean, most likely if you see a question like this, it's going to be multiple choice. So you probably wouldn't have to worry about that.
Sure.
And then number 20, x such that x is an element of the natural numbers, and x is between 10 and 102. And so there's different ways, you could do it if you don't use the or equal to. So you could make this like a 9 if you don't put the or equal to right here, or you could make this 103 if you don't put the or equal to right here.
They would also leave this in existing.
And they have to put the x in there, because you're saying this set is the set of all values of x, such that x is a natural number and x is between 10 and 102. So for set builder notation, yeah, you have to write it this way. If you just say 10 is less than 102, well, that's a true statement.
But you could say the same thing about 19 then, if that's the case, because you're going from 1 to 87 versus 10 to 102.
Natural numbers stop at 1.
I'm not totally sure what you're trying to say.
What I'm saying is the set starts at 10.
Mm-hmm.
Just like the previous set started at 1.
Mm-hmm.
What makes the difference between starting at 1 or starting at 10?
Okay.
Is the same
So the difference between those two is that the natural numbers start at 1. So so what you were saying is, so are you saying basically like why do you need to put the 10 on there?
No, I'm saying why you put the x and then the less than or equal to on 102. That's what I'm saying.
Why do you need to put
That-
the x?
The x and the less than or equal to, because basically what I'm saying is you can do
Right.
the same thing.
Okay, so what,
previously.
but the x is in the the x always
Well,
has to be there.
Yeah, I'm not saying the x is the whole, I'm saying.
So you're saying,
Start at 10, instead of starting at 10, just say less than or equal to, yeah.
so you're saying why can't we just say that?
Yeah.
Okay, well, this right here is just simply a true statement. It has absolutely nothing to do with x. You know, so if I wrote this, technically what I would be saying is that this would be equal to the set of all natural numbers, because I haven't put any other, you know, this just doesn't, this is not telling me anything about what these x values are. You know, so this always is telling me something about x. Otherwise, this is just an erroneous, you know, statement. All right. So for number 21, we could say x such that x is a vowel. Okay, so then let me go ahead and give you a worksheet to start working on. And really, like that number 1, you don't really need to do that. That's number 2. I finally remember a year that was my first semester. You took that class here. Was that your girlfriend? That you took the class with?
No.
No. I thought you guys were dating. Dang it. All right. I'm gonna look at the homework and for a second and see some of those. Wow, I gave out all my worksheets. That means everybody's here today. Awesome. Oh yeah, here we go. So if we look at, I was looking at the homework. Here's the an example with that cardinal number thing that we were talking about. So like this one right here goes 20, 23, 26, 29, so it's counting by threes. And it goes from 20 to 53. So what you do is 53 minus 20 is equal to 33. And since they're counting by threes, you divide that by 3, which gives you 11. And then you add 1 to that. So.
You add one because you're not counting.
Yeah, you're like not counting one of them. Yeah, the answers are for the worksheet are on there at the end, I think. If you want to check your answers. So on that worksheet, we probably don't have the time to do like the whole thing in class, so if you just kind of want to skip around and do like a couple from each section, that might be a good idea. So you can kind of get an overview and make sure you kind of got everything before we move on to the next thing.
Are we turning this in?
Nah, it's just for practice. I'm just letting, if you want to, it's fine, I'm just letting you know that eventually you're gonna wanna throw it out the window. I would really recommend getting one of those.
Yeah, right now I'm usually work on that one Thursday.
Yeah, well, if you can, I'm just saying, it would really, it's like $12 or so, if you can, it would make life easier. Like right now, it seems, like right now, it's not so bad, but some of the stuff that we're gonna get into, like, in a week or two, is gonna be like, you're gonna need a lot better one, just let me know.
Okay.
Can I see yours for a second? So I can show everyone and tell them to buy this one.
I bought it when I put my accounting
Yeah,
class.
no, I mean,
So-
it's just, I'm just letting y'all know, you might save $2 by buying this, but it's so not worth it. Just telling you, you're gonna wanna get the other one, yeah, get this one, if you don't already have it.
I think I have 2 of them, so if you want it, I can bring it if I find it.
If you do, that'd be great. I'm gonna do something. I bought this one for my accounting class.
I think I bought one during the fall, and then I got the course. And don't know what I did with it, so I'll buy another one, so if I find it, I'll bring it.
That one's good, yeah. That one's a couple dollars more, it's also good.
I'm kind of ran out of class stuff while I was
Yeah.
trying to fit it.
Aw. Yeah.
Thankfully, we have 2, so the later ones, when it's switched over, look nice.
Oh, and the other ones, oh, like, the other ones look bad. Yeah, well, you can kind of still read it, I mean, yeah.
Decided to quit on having the letters.
Yeah. Yeah, so if you don't already have a scientific calculator, you're going to want to buy one. I recommend getting this one. It's about $12 or $13, or the next one up from this if you want to, which is like $15 or $17 or something like that. Is good too.
Was like a little less than 13 at Walmart.
Mhm. Yeah, it's like $12.90 something usually. Yep.
I had to get a new folder for my binder so I could have all the notes set in their specific folders for specific tasks. Anybody have any questions about that worksheet?
Most of our, the base, that's from the.
Right. Okay, so, Maybe there's some kind of pattern that they're expecting you to see or something. Yeah, don't worry about that. That's 4B. I mean, honestly, as you can see, I just got this from the internet, so not everything on it is like specifically something that I would expect you to know or whatever, but it's pretty good. But there may be a couple weird things on there. Yeah, so like on 4B, the answer was, x such that x is a factor of 18. So I wouldn't expect you to figure something like that out, honestly. Yeah, a lot of those on number 4 are kind of weird.
One of the sentences on the formulas that you have to.
What now?
4 seems to want a lot of sentences.
Yeah. Uh-huh. Yeah, I wouldn't worry too much about most of those ones on number 4.
Or you can also make the one that continues with XS. That one, the one with the 2 is actually like the cheaper one, and the one without the 2 is like the newer, like slightly fancier one. But either way, one's 13, the other one's like maybe 16. Either one of those would be good. Yeah, I'd recommend that. Right now it doesn't really make that much difference, but later on it will. Because we're going to be using, like on chapter 8, we're going to be using a calculator with time.
Anybody else have any questions, like about the worksheet or anything? Number 8, I retyped it. It says, from the sets given below, select the equal sets. Yeah, I don't know why it cut it off like that, so that's why I did retype.
Let's just ask for which letters.
Yeah, like which ones are equal to each other. All right. Any other questions before we move on to the next section?
Yeah, your 10 sections.
Number 10 is crazy.
Yeah. You got words in plain, you got words in plain, but and then it's supposed to be the same question, but according to the answer key, but it's 2 questions.
Okay, so like part B, you're saying? So the letters in the word plain, P-L-A-N-E, and the letters in the word plain, P-L-A-I-N. So those 2 sets would be equivalent because they would have the same number of elements, but they would not be equal because they don't have the exact same elements. All right, so let's go ahead to section 2.2, which is about subsets. And I mentioned this a little bit earlier. So A is a subset of B if and only if X is an element of A implies X is an element of B for all values of X. So that sounds makes it sound more confusing than what it is. Like how we talked about on the last section, if we just look at that real quick, how we said the 4 and the 6 thing. So like right here when we said, okay, so this is not an element of A, but this would be a subset of A because it's just a subset of those elements because those 2 elements are in there. So the set containing 4 and 6 would be a subset of A in that case. So that's basically what we mean by a subset. Okay? And this is the symbol we use for is a subset of, and if you cross that out, it means it's not a subset of. And then we have a proper subset. So basically, most subsets are proper subsets. A proper subset is just a subset that is not equal to the original set. Okay? So the only type of subset that's not a proper subset is just going to be the exact same set. So here's an example. A is the set of all natural numbers that are greater than 6. oh, and by the way, here's the notation for a proper subset. So it's kind of like, you know, less than versus less than or equal to. Same kind of idea. So for A, if I were to list those out, it would start with 7, 8, 9, 10, and it would keep going forever. Okay, so that's the same thing as just writing A using the roster method. Alright, so we want to fill in the blank with either is a subset, is a proper subset, or is not a subset. So is B a subset of A? No. So is not a subset of. Is A a subset of B? No. A is not a subset of B. Is C a subset of A? Yes, because C is a set containing 8 and 9, and 8 and 9 are in A. Okay, could we also say that it is a proper subset? Well, since it's not equal, yes, you could. Alright, so C is a subset of A. We could also say that C is a proper subset of A, because C is not equal to A. Alright, is the empty set a subset of C? Yes, actually it is. So basically the subset, or the empty set is a subset of anything, any other set. Okay, because in order for it to be a subset, you have to be able to say that every single element from here, like if anything is an element of this, it's also an element of that. And I mean, since there are no elements here, you know, that you can make that is a true statement. So that's one of those things they would call vacuous. It's vacuously true. It's true because you have no elements here to do anyway. So basically, this empty set is a subset of anything. And as long as it's not equal, so the other set that we're saying it's a subset of is not the empty set as well, we can also say it's a proper subset. Okay. The set containing 1, is that a subset of B? Yes. And it's also a proper subset since there are other elements in there in B other than 1. And then is C a subset of C? Yes, but it is not a proper subset since they're equal.
I understand the proper versus regular subset.
The only time that, basically this is the only type of example where you can say that it's a subset but it's not a proper subset because these two things are equal. It's just like, you know, saying, you know, less than or equal to, kind of, you know. So if it's a subset and they're not equal to each other, it's also going to be a proper subset. Because this has more elements than this. Alright, so true or false, the set containing 8 is a proper subset of C. True. Alright. Number 8 says 9 is a proper subset of C. False. Very good. Because it's, so 9 is not a set. So if it's not a set, it can't be a subset. Alright, it's just a number. So if it was the set containing 9 with the little curly brackets on it, then it would be true. So there is a difference between just the number 9 and the set containing just the number 9. Those are two different things. So number 9 is saying the empty set is a proper subset of A. That is true. And then number 10 says B is a subset of the empty set. False. So the empty set is a subset of all the other sets, but it's not, you can't switch that around. So, because in order for this to be a subset of this, I have to be able to say the elements from B, all of these elements are also in here, and there's nothing in here. So, for example, B was what, 1, 2, 3? So 1 is an element of B, but 1 is not an element of the empty set. Therefore, it's false. And then number 11 says the empty set is not a subset of C. That is false because the empty set is a subset of C. It's a subset of everything, every other set. All right. Any questions about that? Okay, list all the subsets of B. Okay, so B, remember, was a set that contained 1, 2, and 3. So I'm going to start with the empty set. I'll kind of do it systematically so I don't forget anything. So then I'm going to list all the subsets that only have one element. So the set containing 1, the set containing 2, the set containing 3, and then let's do all the ones that just have 2 elements in them. So the set containing 1 and 2, the set containing 1 and 3, and the set containing 2 and 3, and then the whole thing. So those are all the subsets of B. So let's see how there's 1, 2, 3, 4, 5, 6, 7, 8 of those. And there's actually a formula right here to tell you how many subsets a set will have, which is equal to 2 to the power of the cardinal number. So there were 3 elements in B. 2 to the 3rd power is 8. So there's 8 subsets of B. If there was 4 elements, 2 to the 4th is 16. There'd be 16 subsets. All right, so find the number of subsets for this set. It has A, D, E, F, G, H. So the cardinal number, 1, 2, 3, 4, 5, 6. So there are 6 elements in the set. So there would be 2 to the power of 6 is equal to 64. You can do that on your scientific calculator. To the power of is the caret, if you didn't know. And then, so there's only one subset that's not also a proper subset, which is the set itself. So to figure out the number of proper subsets, you just subtract 1. So there's 63 proper subsets. You figured it out? Okay. Okay, so pretty much all the subsets are also proper subsets except for one, which is the actual set itself. So that's why you take the total number of subsets and subtract 1, and that's the number of proper subsets. Okay. So let's see. Number 14. A is a set of all WC students. B is a set of all female WC students. C is a set of all married female WC students. So true or false. C is a subset of A. True. Okay. Well, it is also a proper subset. So it's a subset, it's also a proper subset. Either statement is true. Just like, this is a true statement, and this is also a true statement. So it's the same thing with the subset thing. Alright, so again, true or false, if X is an element of A, then X is an element of C. That's false. It would be the other way around. Yes. It's not. Or being the operative word. That's true. See, this is why we should do chapter 3 before we do chapter 2. I should this whole logic. The or is it means either one of those statements could be true. Like if I said, I'm either a man or I'm a woman. That is a true statement. Because one of those statements is true. When I say or, I can say I'm either I'm a woman or I'm 8 feet tall. That is a true statement. Because one of them is true. Only if you use the word or, only one of those statements has to be true, not both. Like if you said, tomorrow I'm either going to go to school or I'm not. Well, obviously both of those statements can't be true, but one of them is, So, yeah. Okay. Let's see. Any other questions about any of that stuff? This is why this is so much fun. I just love this. Okay. Y'all think I'm insane. It's okay. All right. 2.3. Okay. So some operations that we can do between multiple sets. Union and intersection. All right. So the union of two sets, so when you see this is read as A union B. All right, that is a set that contains all of the elements of A as well as all of the elements of B. Okay, so union is often associated with the word or. So if something is in A or if it's in B, then it is in A union B. So like the example that we started off with in section 2.1, we had A was the set containing 1, 3, and 10, and N was the set containing N, X, 0, 10, and 23. So A union B contains all of those elements. Okay, and like 10
was the only element that was in both of them. We only list it one time. All right, because we had A contained 1, 3, and 10. B contained NX 0, 10, and 23. So they're all in the union.
And then the intersection of two sets is a set that contains elements that are in both A and B. So if something is in A and that same thing is also in B, then it must be in the intersection of A and B. So you have the union symbol, which looks a lot like a U, but it's technically not. When you're doing your homework, they'll have like some symbols. You'll be able to click on that symbol if you need to. And then the symbol for intersection is the same except for it's flipped over. And to me, it makes me think of like an N for intersection. So if you have trouble remembering which is which, I mean, U looks, it looks like a U and it stands for union, and then this one looks like an N and it stands for intersection. Then we have the complement. Okay, so A complement, or I usually say A prime, consists of all of the elements in the universal set that are not an A. So you kind of have to define what your universal set is, and then you can figure out everything that's not an A. So a great visual tool that we can use for all of these things is a Venn diagram. So let's say that this circle over here represents set A, and then this circle over here represents set B, and the big rectangle represents the universal set. So the purple section where they overlap, that represents the intersection. And then the entire shaded area, all of this, represents the union. Alright, so find the union and the intersection of the following pairs of sets. Alright, and I always like to use a Venn diagram. And the easiest one to do is the intersection, see what they have in common. So they both have 1 and 5. So in your Venn diagram, you would put 1 and 5 in the intersection. And then on your Venn diagram, you would put the other elements from A over here, so -7 and -3 over here, and then the other elements from B, 9 and 13, are over there. So the union would be -7, -3, 1, 5, 9, and 13. And you don't necessarily have to put them in order, but I just like to do it that way. All right, any questions about that? All right, so number 2, set A contains A, E, I, O, U, set B contains C, D, F, G. So what elements do they have in common? None. So the intersection is the empty set. So on your Venn diagram, you would just put all the elements of A over here and all the elements of B over here. So the union I don't feel like putting these in order. I'm just going to do it this way. Okay. So number 3, the universal set is the set of all natural numbers. And A is all the natural numbers that are even. So we could write that using the roster method if you want. 2, 4, 6, 8, and so on. And then we've got B, looks like it's all the natural numbers from 1 to 12. Alright, so if we did the union of these two, we would have to start with 1 because, and I'm going to try doing them like in order, so that'll make a lot more sense. So start with 1 because B has 1 in it. And then they both have 2. And then B has 3. And they both have 4. And then you're going to have, let's see. Okay, so we're going to also have, because of B, we're going to have 5, 6, 7, 8, 9, 10, 11, and 12. Alright. And then, after that, we're just going to have the even numbers from A. So then we're just going to have like 14, 16, 18, ... like that. Now the intersection is just going to be the even numbers that are going from up to 12. So that's just going to be 2, 4, 6, 8, 10, 12. All right. And then A complement, the complement of A, so everything from the universal set that is not in A. So basically that's going to be all of the odd numbers. So we could do X such that X is a natural number and X is odd. Or we could just kind of do the roster method. Or we could do 1, 3, 5, 7, etc. Either way, you could write it. Okay, so A union B complement. So the complement of A union B. So the elements that are not in the union of A and B. So, you know, the elements that are in the universal set, they're natural numbers, but they're not in A, they're not in B, so they're not in here. So everything from 1 to 12 is included in here. So the first one we would have 13, and then we would have 15, 17, 19, and then all the other odd numbers. So it would be 13, 15, 17, 19, and so on. Or you could say something like all the odd numbers that are greater than or equal to 13. Let's say it could be said that way. And I'm not even sure if you really need to say that it's a natural number. I think when you say that it's odd, it's already implied that it has to be a natural number. Same thing with even. Alright, so B complement. So B covers everything up to 12. So the complement of B is just everything that's greater than 12. So you might just say X such that X is a natural number and X is greater than 12. or you could say greater than or equal to 13, or you could say 13, 14, 15, 16, 17, etc. The one on the left is easy for me to do, you know, the little braces. The one on the right still gets me sometimes. All right. Any questions so far? All right, so A prime intersection with B. So these are the elements that are not in A, but they are in B. So, let's see. They're not in A, but they are in B. So it would be the odd numbers that are in B. So it would be 1, 3, 5, 7, 9, and 11. All right, what about A intersection with the empty set? So anything intersected with the empty set is just the empty set, because the intersection can only, so any element that would be in the intersection has to be in both of these. And since nothing is in here, nothing can be in the intersection. And what about B union the empty set? It's just B. So you could just write B, or you could just write out what B is. Either way. So yeah, anything that's union with the empty set is just whatever this is. So, you know, because the union has to contain everything from B and everything from the empty set, which is nothing, so it's just B. So it's kind of like B plus nothing. And this is kind of like, you know, almost like multiplication, you know, like if you were, when you multiply something times 0, you get 0. Kind of like that. Okay, so here's a Venn diagram with random crap in it. And just, you know, note that A and B are just the names of the set. They're not elements of anything. U is just saying that this box is the universal set, so U is not an element of anything. All right, so the union of A and B in this case is all that silly stuff. So you have a star, and you have a fish, and you have a heart, and you have a smiley face, and then you have the number 73. That's the union. All right, so A prime, in other words, the complement of A. Why do the colors, I can't stand it. Hang on. Yeah, okay. This is supposed to be red, and this is supposed to be blue. Okay, now it's all good. All right, so A prime, everything that is in the universal set, but it's not an A. So that would include the smiley face, and the 73, and the word green. And then B prime is everything that's in the universal set that's not in B. So that would include the star and the fish, and the word green also. The U is not an element of anything. It's just there to tell you that this box is the universal set. I don't know, I guess maybe I should put it outside the box. Maybe that would help. Alright, so then A prime intersected with B. So those are the things that are not in A, but they are in B. So that is smiley face 73. And then A union B complement, that is everything that's not in the union. So that the only thing is the green. And then the intersection is just the heart. All right, let's see, here's one that's a little bit more complicated. All right, so you probably want to figure out this part first, which we already did. So this part right here, the complement of A union B, is just green. And then union that with B. So the answer is going to have green, and then it's going to have all the stuff from B, which is those three things. So it's got green, it's got the heart, and the smiley face, and the number 73. Okay, any questions about any of that? Okay, so here's a formula which states that the number of things in the union is equal to the number of things in A plus the number of things in B minus the number of things in the intersection, because if you add all the stuff from A plus all the stuff from B, then anything that's in the intersection is getting counted twice. So that's why we have to subtract that off to get the number of things that are in the union. So, like for example, that example that we just looked at, there's a total, like the cardinal number of A is 3, and the cardinal number of B is 3, right? And if you add 3 plus 3, that's 6, but then you have to subtract 1 because this part was counted twice. So the cardinal number of the union is actually 5. So if A has 10 things, B has 10 things, and A and B have 2 things in common, how many things are in A or B? So you just do 10 plus 6 minus 2 equals 14. All right. All right, so here's another example. This one has 3 circles. You got A, B, and C. All right, so the universal set is the natural numbers up to 10. So I always find it helpful to just go ahead and like kind of write this out in roster method. So that's the universal set. A is all of those numbers from the universal set that are also even. So A. Oh, it's frozen? Oh, sorry. Okay. All right, so the universal set is all the natural numbers that are less than or equal to 10. And then A is all of those numbers from that universal set that are also even. So A would have 2, 4, 6, 8, and 10. And then B is all of those numbers from the universal set that are also odd. So B would contain 1, 3, 5, 7, and 9. And then C is all of those numbers from the universal set that are between 2 and 8, not including the 2. So it actually starts with 3, so it's 3, 4, 5, 6, 7, 8. All right, so we have A, B, and C. And then this box represents the universal set. So what elements would go in the intersection of all three of them? That's always the best place to start. Nothing. Okay. All right, so there's nothing in there. And there's because the reason is because there's nothing that are in common between A and B. So there's nothing in here, and really don't do that. Don't mark, don't do that. Just for now, so we can remember we already talked about those. And then, let's see, between C and B, what would those have in common? 3, 5, and 7. So those go right there. And then between A and C, you would have 4, 6, and 8. Okay. All right. So what else would we fill in for just what's in A but not anything else? 2 and 10 go here, and then 1 and 9 go here, and then anything here? No, nothing's there. Okay. And then I think that's it. Okay, and that takes care of everything. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's also nothing that's in this area that's outside of all three of the circles. All right, so that would be what our Venn diagram would look like. All right, so A intersection with the universal set. That's just A. Or in other words, you could either just write A, or you could list what A is. Or you could even write the set builder notation, I guess. Okay, so that's kind of easy. What about A intersection with C prime? So things that are in A, but are not in C. 2 and 10. All right, then we have the complement of the intersection of B and C. So these are things that are not, anything from the universal set that is not in the intersection of B and C. So that would include basically everything except for the 3, 5, and 7. It would include everything else that's not in here. So that's going to include 1, 2, 4, 6, 8, 9, and 10. Okay. So this circle represents people that like math. This circle represents females. Okay. So the males would basically be anyone who's not female. So we have Joe, Jim, Ronnie, Brad, and Tim are all the males in this thing. I swear these gender questions get trickier every semester. I'm like, let's just not even go there, guys, man. Okay. And then which of these people like math? Okay, so that includes Ronnie, Jim, Joe, Leslie, and Sydney. What? Oh, which males like math? Good call. So those are the Ronnie, Jim, and Joe. Yeah. And then which ones just like math? So Ronnie, Jim, Joe, Leslie, and Sydney. All right. Okay, and so that is the end of the notes for today. Our test is on Thursday. This is a practice review for that test. The answers for that are on Google, but I would recommend that you actually try to work it out. Don't just look at the answers. Thursday? The test is Thursday. So tomorrow, so hopefully y'all will go home and work on this tonight. And then tomorrow we'll have a quiz over chapter 2, and y'all will have a chance to ask me any questions about the test. You everybody get one, or?
You got it.
Somebody leave, or did somebody not get a copy?
Yeah, I got it left right here.
Okay. Okay, so you're supposed to know that you're supposed to go to wc.mylessons+, and you're supposed to type in your student ID number. It's literally just it's 8-digit number. That's all it is. The password is your date of birth. Okay.
Did you use the one that's on your Toyota card?
Okay, so your number is also like on your schedule.
I think I'm
Yeah.
183.
And like if it has a 0 in the front of it, don't use that 0 that's in the front of it.
Okay, I'll try and.
Okay, so I mean, if you want, you know, I mean, you can go over to the Success Connection and just try it out right now, and I can come over there and make sure that you got it, or see if you need any other help. You want to do that?
That's fine.
Okay.
I'll get it to work tonight.
Okay.
And that worksheet, you want us to bring it completed or?
No, you don't have to.
I'm just confused with the two first questions of the quiz.
Mm-hmm.
Yes, if you don't mind, can you explain that to me?
Mm-hmm.
Like the one with pens and the one with pens?
Mm-hmm. So when it ends in TH,
Yes.
all of those are the ones that are after the decimal point.
Oh, okay.
So
this is the first one after the decimal point, that is the 10th place. So, and then you've got, so this is tenths, this is hundredths, and then it would be thousandths. And then when you go from the decimal point and you go to the left, that's ones, tens, hundreds.